Hello, I'm Graham and welcome to my product review for this BESTEK 7 outlet surge and overcurrent warning power strip. And as you can see, it's got three 13 amp outlet sockets, and behind these protective rubber covers are four USB outlets. Now the unit itself measures 28 by 6 by 3.5 centimeters and is supplied with about a 2 meter length of heavy duty 1.5 square millimeter cable, which is the correct rating for a device of this type up to 3000 watts. Now it's interesting to note that the cable is terminated in a molded plug, which is correct for the BS standard of 1363, and in fact the fuse itself is the correct specification for these devices, so it's a 13 amp fuse, and to conform to the BS 1363 standard it must have the welded fuse wire, current end, and the cartridge filled with sand. Now I haven't broken this fuse obviously to see whether it's sand filled, but the outward appearance is that it does conform to the correct 1362 specifications. The whole power switch is protected by an on-off switch, and that supplies power to the three 13 amp sockets and to the switch mode power supply, which is supplying the 5 volts USB outlet port here. Let's plug this in and we can see the indications we have from this unit. Well, I have the power strip connected to my power meter so we can measure the various currents taken at the various stages of charge, and if I turn on the power strip you notice that the power meter goes up to about 1 watt, so that's the standby current for the switch mode power supply when it isn't providing any power to any charging units. Notice there is a neon light that's illuminated in the power switch, and that tells us we have power available to the three 13 amp sockets, and the switch mode power supply, its output is indicated by the green LED illuminating to say that we've got now 5 volts available at those USB outputs. Let's have a look now at the USB sockets. You notice we've got two sockets here which are both rated up to 2.4 amps, a socket which is rated at 1 amp, and the final socket is probably supplied with one of these smart ICs which will provide the right charging current for the device that's been attached. So it will provide anywhere between 0 and 2.4 amps. The total capacity for the switch mode power supply is 5.2 amps, so you can't exceed 5.2 amps. If you try to connect four high power devices, then obviously it's going to reduce the power to some of those devices to limit the output current. So let's plug my iPod mini into the auto socket first of all, and we should see about 1.5 amps. We're actually showing 5.06 volts and 1.5 amps being supplied to the iPad to charge it. So if I try to put that into the 1 amp socket, it will limit the power, and we've got now 0.94 amps. But it should provide the full power of the 1.5 amps in both of these sockets. And it's showing 1.39, 1.4 for each of those sockets. If I charge a lower power device like this Samsung Galaxy Tab here, then if I plug this into the socket, we've just got 0.75 amps, which is about the right charging current for that device. Notice with the Samsung Galaxy taking 0.75 amps, the power meter has gone up to 5 watts. If I reconnect the larger current device, the iPod mini, then the charging current has now gone up to 9 watts. So it's not a heavy power consumption, and it's safe to leave this plugged in to charge your devices. I've had this running for several hours and I measured the temperature of the case and it was just less than 40 degrees, so it is running fairly cool. In a moment I'll show you the inside of this unit to show you how well it's constructed and whether it complies with safety regulations for things like separation of the components on the switch mode power supply and the termination of wiring, etc. But first I wanted to demonstrate the overcurrent warning of this device. It's limited to 3000 watts, so that is 13 amps, and if you try to exceed that you'll get an audible warning to say that you're overcurrent. So I'm going to plug in first of all a 3 kilowatt kettle, which is the 3000 watts, and we should see 3000 watts being displayed on the power meter, and the strip should be quite happy to supply that. If I try to exceed the 3000 watts by adding an additional load, the power strip should give me an audible warning that we are exceeding the current. So let's put a load in here and test that out. Well, I've got two mains loads connected to the power strip. One is supplying a 3 kilowatt electric kettle, and the other is providing power to a fan heater, which I can switch the load to either 1 or 2 kilowatts. So when I first turn on the kettle, the strip will provide us 13 amps or 3000 watts, and we should see that on the power meter. I'll then turn on the fan with a 1 kilowatt load, and that will put the total demand up to 4000 watts. It's just within the rating of the total unit, which is 4000 watts, but we should hear an audible warning device going which tells us we are actually exceeding the peak current of this unit. I'll turn on the kettle first of all and hope that the noise isn't too much from the kettle, and then you can actually hear the audible warning device when I switch on the fan. So I'll turn on the kettle first. You can see we've got 2959 watts, so that's well within the rating. And I'm now going to turn on the fan to the first rating. You can probably hear the beeping as we've got 3900 watts, which is beyond the load of this unit. Apologies for the noise of this kettle. This is one of the noisiest kettles we've ever bought, but it did demonstrate the audible warning device kicked in after we put the second load on there, which took the peak demand over 3000 watts. Looking on the back of this unit, you notice that it can be wall mounted. There are two fixing positions, so you can actually hang this on a wall if you wanted to. And I'm going to have a look inside the unit to show you the construction, and access to that is gained by the 6 screws which are hidden behind these rubber plugs. Now these serve two purposes. If you're going to put this down on a shiny surface, these rubber plugs will stop the unit scratching the table or whatever surface you're on, and it also stops it sliding around. Okay, I'm going to open this up now and show you the internal components. Well, the image on screen now is the actual inside of this power strip. Notice the mains input cable is correctly strain relieved as it enters the unit. Next to that we have the power on-off switch, and that is an area that I would have suggested that we should have had a bit more separation between the wiring from coming in through that strain relief and being attached to the switch. It's very, very close. Fortunately, there's no movement of the cable there, so there's no danger of that chafing against those sharp-edged terminals. But a little bit more separation might have been in hand in there, but it's not a major consideration. The rest of the soldering and spot welding of the bus conductors down the unit are acceptable. And if you look at the other end of the unit, we have the switch mode power supply printed circuit board. Now the first components to look at on there are the surge varistors, so they protect the 13 amp power sockets and the switch mode power supply from any overvoltage transient spikes. Sometimes you get spikes on the mains when heavy loads have been switched in nearby, and this unit will then protect your devices which are plugged into the 13 amp sockets from any overvoltage spikes. The actual switch mode power supply, if we look at the isolation between the input and the output, you notice that there are some holes drilled in that printed circuit board to increase the electrical separation between the input and output, and that's very important with devices that are supplying you low voltage DC from mains derived components. The mains input rectification, they've used the correct rating of capacitors on the output, so it looks as though this supply has been designed with safety in mind, and I've no concerns about leaving this unit plugged in overnight charging devices. It does look as though it has been correctly specified. So there's my review for the BESTEK 7 outlet strip, 3000 watt AC rated for the 13 amp power sockets and 5.2 amps for the USB 5V outlets. Thanks very much for watching. Please do take care, and I'll see you in my next video. Goodbye for now.